And next, let's move on the diffuse gamma ray analysis. To extract a small diffuse gamma ray signal embedded in the huge cosmic ray background, we adopted a tight muon cut, which is just one order of magnitude tighter than the standard analysis, as shown by red lines. As a result, we succeeded in the reducing the cosmic ray background 10 to minus 6 above 400 TeV energy region. And then here I will show you the gamma ray-like events distribution after the tight muon cut in the equatorial coordinate. Blue point shows the observed event arrival event distribution in 3 different energy range. Upper one is between 100 TeV to 160, and the middle one 160 to 400 TeV, and the bottom one above 400 TeV. And you can see that some events concentrate on along the galactic plane, as shown by solid curve. And at the highest energy region, so 38 events were survived in our field of view after the tight muon cut, almost background free, you can see. Among them, the 23 events are located within the galactic latitude less than 10 degrees. Okay, then as shown here, the latitude profile, galactic latitude profile. Red points show the observed data across our field of view, including source contribution. You can see the clear peak is seen at the galactic plane in different energy region with a high statistical significance. Compared with the gray shaded histogram modeled by Lipari and Barnett, assuming the hadronic scenario. Okay, then as shown here, the energy spectrum of the ultra-high energy diffuse gamma ray. Upper panel shows the energy spectrum in the inner galaxy region. This target region completely same as the previous work by the Argo IBJ blue point around 1 TeV energy region. And red point shows our observed data after the excluding a contribution from the non-TeV sources. And then these measured flux are compared with the diffuse gamma ray model, assuming 2 different hypotheses in this paper. One is cosmic ray spectrum is identical in whole galaxies, solid curves. The other one is cosmic ray spectrum is harder, getting closer to the galactic center, dashed curve. Our measured flux are overall consistent with both model, assuming the hadronic scenarios. And lower figure shows the outer galaxy region was searched by the Casimir experiment long time ago. Our data measure our data reasonable agreement with the models, except little bit enhancement highest energy beam. And then here I would like to mention the Cygnus Cocoon region. We first time claimed this high energy event around the Cygnus Cocoon region above 400 TeV energy region. This is a gamma-like distribution above 400 TeV. You can see the events as seen along the galactic plane like this. Among them, we found 4 events within the some radius circles from the Cygnus Cocoon region. And these events can extend energy spectrum up to the 1 PB energy region. Our flux plotted here. So already Russell collaboration reported more detailed spectrum, but our spectrum also consistent with Russell spectrum. And then I will show you the recent Russell diffuse gamma ray measurement compared with our result here. Red point shows the Russell flux. This is a little bit, not a little bit, a few times lower than our flux, but we cannot directly compare with each other because Russell collaboration masked much more region along the galactic plane like this. However, our measurement may include some unresolved point sources. So we checked that. As you know, the Russell collaboration reported more than 40 ultra high energy sources. Here we compare the first Russell catalog and Tibet diffuse events. Blue circle shows the Russell ultra high energy sources, and red point shows the Tibet diffuse event. Surprisingly, our diffuse event not coincided with the Russell sources except Chingas-Kokon region. And this is IceCube diffuse neutrino result recently published in science paper. They detected diffuse neutrino flux along the galactic plane at 4.5 sigma level. And in this paper, they claimed the IceCube neutrino flux smoothly connected to the neutrino flux estimated from our measurement, assuming the neutral pion model best fit flux. It's a very strongly supports cosmic ray origin of the our measurement, regardless point source or diffuse. And then next, let's move on the some pivotal candidate. First one is a very famous one, SNRG-106. This is the energy spectrum extended up to the 100 TeV energy region. Red point shows our measured spectrum. However, this measured flux can be explained by a hadronic scenario and leptonic scenario without any other wavelengths data. And left figure shows the gamma ray image. The gamma ray excess is very coincident with the molecular cloud shown by black contour and cyan contours and SNR. However, our gamma ray excess is shift from the pulsar. This is a support hadronic scenario. So if we assume the hadronic scenario, the proton cutoff energy estimated to be 500 TeV energy, and the proton total energy is 5 times 10 to 47 ergs, assuming the distance 800 parsecs. And this source, MAGIC, also reported gamma ray signal, SNRG-106. They found high energy emission between 6 TeV to 30 TeV, which are consistent with our result. And they also investigate multi-wavelength energy spectrum, including X-ray observation. Their spectrum fitting support favors a hadronic model because this X-ray observation constrains somewhat leptonic scenario. Okay. So next candidate, Hess source is J1843-033. This is a very similar situation to of the previous G106. The gamma ray spectrum extended to the 100 TeV energy region, and our gamma ray excess is coincident with the molecular cloud and SNR. If we assume the proton acceleration in this source, the proton cutoff energy is 500 TeV, and the proton total energy is about 10 to 49 ergs, assuming the distance 9.6 kiloparsec. And next candidate also has source J1849. This is published in APJ, which is a middle-aged pulsar in the nebula. But we cannot find any SNR candidate around here. The gamma ray excess also coincident with molecular cloud. Little bit difficult to see the green contact here. And energy spectrum looks very flat. If we assume the hadronic scenarios, proton cutoff energy estimated to be well beyond the PV energies, and the proton total energy 10 to 49 ergs if we assume the distance 7 kiloparsec. Okay, so let me summarize my talk. We successfully observed the ultra-high energy diffuse gamma ray and some pivotal candidate. And now there are a lot of ultra-high energy sources mainly discovered by Russell experiment. However, there are no sub-PV instrument, wide field of view instrument in the southern hemisphere. So next step goes south. Some projects are ongoing or planned, such as Alpaca, Mega Alpaca, SWGO-CTA, and as well as some next generation neutrino experiment. Next session, Marco